Good afternoon, Algebra 2 students. One of the skills that you'll be learning in this unit is how to perform operations such as addition and subtraction on rational expressions like the ones that you see here. Now, before we can add or subtract two rational expressions such as these, we have to have a great understanding of how to add and subtract fractions in general, such as the ones that you would see here. Now, in order to add or subtract two fractions, the key is you must have the same denominator. Now, before you can find a least common denominator, you have to understand how to find the least common multiple of two numbers, and that's a skill that we're going to briefly practice right now. Here we're asked to find the least common multiple of the numbers 18 and 24. Now, there's two ways to go about doing this. The first method would be to simply list all of the multiples of each number until you find a multiple that they have in common. For instance, number 18 has the following multiples: 18, 36, 54, 72, 90, and so on. For the number 24, is the multiples 24, 48, 72, 96. Now, we could keep going with both of these numbers. We're going to stop there because we see that they share a common multiple of 72. And this is the first multiple that shows up as we list all of the multiples of each number. Therefore, 72 would be the least common multiple of 18 and 24. Now, a second method of obtaining the exact same result would be to find the prime factors of each number. If I want to find the prime factors of 18, I could use a factor tree to help me out. The factors of 18 I can start with would be 2 and 9. 9 can be factored further into 3 times 3. 2 and 3 are both prime factors, so I could say that the prime factorization of 18 is equal to 2 times 3 squared. I will then do the same for the number 24. 24 I can break into the factors 4 and 6. 4 can be broken down into 2 times 2, and 6 can be broken down into 2 times 3. So if I wanted to write the prime factorization of 24, I would write it as 2 to the third power times 3. Now, if I'm looking for the least common multiple of 18 and 24, as we are here, I could use their prime factors to figure it out. The least common multiple of these two numbers will be the product of each of the factors that appears, the greater number of times that it appears as a factor. Let me explain. I see that I have 2 as a factor once in the number 18, but I have 2 as a factor 3 times in the number 24. If I have to choose between using 1, 2, or 3 2's within my least common multiple, I need to choose the greater number of times that it appears, so I know that 2 to the third power will be part of my least common multiple. Using the same idea for the factor 3, I have to choose between 3 squared, 2 3's, or just 3 to the first power. Well, I'm supposed to take the greater number of times that it appears as a factor, so I'm going to choose 3 squared. If I were to then take 2 to the third power times 3 squared, 2 to the third power being 8, 3 squared being 9, 8 times 9 would be 72. The exact same number that we got by listing our common, or all the multiples of each number. Now we'll try an example together. Find the least common multiple of 12 and 20 as it shows on your sheet at home. If you'd like to pause the video and try it on your own first, please do so now. If I want to find the least common multiple of 12 and 20, method 1 would be to simply list all of the multiples of each number. Listing the multiples of 12, I would have 12, 24, 36, 48, 60, and so on. If I wanted to then list the multiples of 20, I would have 20, 40, 60, 80, and so on. But obviously I can stop there because I see the first common multiple that they share would be the number 60. So the least common multiple of 12 and 20 is 60. Now, can we get the same result using the prime factorization of each? Let's take a look. Prime factors of 12, well, I start with having 3 times 4. 4 can be broken down into 2 times 2. So the prime factorization would be 2 squared times 3. If I do the same for 20, 20 can be broken into 4 times 5. 4 is 2 times 2. 5 and 2 are both prime numbers, so I would write the prime factorization as 2 squared times 5. Now, as I write out the numbers that make up the least common multiple, each factor that I see in the prime factorization of both numbers needs to be represented. And I choose it the greater number of times that it appears as a factor. So as I look at it, I have to make a choice between taking 2 squared or 2 squared. Now I'm supposed to choose it the greater number of times. In this case, I have the same. I have 2 2's in one factor and the 2 2's in the other as well. If that's the case, if it's even, then I only have to use 2 of the 2's. I don't need to overlap them because, again, we're looking for the least common multiple, and choosing it without having to share or repeat factors makes it the least common multiple. So 2 squared is part of my least common multiple, as is 3, because I have to choose between 1 3 or no 3's, as is 5, because I have to choose between 1 5 or no 5's. Multiplying these all together, 2 squared is 4, times 3 is 12, times 5 is 60. The same number that we got by using the list that we have on the left. Now, when we add or subtract rational expressions, thinking fractions, we need to have the same denominator in order to do so. So as I look at the expression 1/12 plus 3/20, at the moment, these two fractions do not have the same denominator. So what I need to do is I want to find the least common denominator between these two fractions. The least common denominator being the least common multiple of 12 and 20. Well, as we showed before, the least common multiple of 12 and 20 is the number 60. So my job is to then take these two fractions and change them so that they both have a denominator of 60. In order to accomplish this, I'm going to multiply the fraction on the left, 1/12, by whatever factor it's missing in order to become 60. Well, 12 would be missing the factor of 5. 12 times 5 would be 60, so I'm going to multiply the denominator by 5. If I multiply the denominator by 5, I also need to multiply the numerator by 5. 5 divided by 5 equals 1, and any number times 1 is equal to the same value, according to the identity property of multiplication. Now, to turn 3/20ths into a number of 60ths, I have to multiply that by whatever factor is missing. Well, to turn 20 into 60, I have to multiply by 3. If I do something to the denominator, I have to do the same to the numerator. Now, once I do this, I multiply 5 times 1 and get 5. 5 times 12 and get 60. I have 5 60ths for the first fraction, plus 3 times 3 is 9, 20 times 3 is 60. So I have 5 60ths plus 9 60ths. Now that I have the same denominator, I add the numerators together, 5 plus 9 being 14, and write them over the common denominator of 60. Once you have a common denominator, nothing needs to be done with it. It simply will be the denominator of your answer. At this point, usually we're going to write our rational expressions in the simplest form. 14 over 60 can be reduced. 14 is the same as 2 times 7, and 60 is the same as 2 times 30. Writing each of these expressions as a product of two factors allows me to then divide or cancel out a common factor of 2, 2 times divided by 2 being 1, which leaves me with a final answer of 7/30ths for that first expression. Now, if I were to do the same thing with subtraction, allowing you to write this down if you need to, I would again need a common denominator. Between 15 and 30, I can probably quickly figure out that the least common multiple of 15 and 30 is 30. Now, to turn 15 into 30, I need to simply multiply by 2. And if I multiply the denominator by 2, I also must multiply the numerator by 2. This will turn my first fraction into 22/30. My second fraction is already a number of 30ths. I can leave it as is. Now that I have a common denominator, I add or subtract the numerators. In this case, 22 minus 7 is 15, which is written over the common denominator of 30. Again, I can reduce at the end. 15 can be written as 1 times 15, and 30 can be written as 2 times 15. This allows me to cancel a common factor of 15 and leaves me with a final answer of 1/2. This same method of finding common denominators in order to add or subtract fractions works even if I have 3 fractions at the same time. For this expression, I see a denominator of 6, denominator of 15, and a denominator of 3. If I want to find the least common denominator between these 3, I could look at the factors that make up each of these numbers. I know that 6 is equal to 2 times 3. I know that 15 is equal to 3 times 5, and 3 is obviously a prime number as is. This leads me to believe that my least common multiple is going to be a product of 2, 3, and 5. 2 times 3 is 6, times 5 is 30. So I believe my least common multiple is 30. And if you look at the 3 denominators and think it through, I'm sure you'll find that that will be the first multiple that they have in common. Now, in order to change each of these fractions, I'm going to multiply both top and bottom by the same value. 5/6 changes into a number of 30ths if I multiply the top and bottom by 5 over 5. This will give me 25/30ths. To change 7/15 into a number of 30ths, I should multiply by 2 over 2, which will give me 14 over 30. The final fraction, 2/3, if I want to change that into a number of 30ths, I would need to multiply by 10 over 10, which would give me 20/30ths. Now that I have a common denominator of 30, I can add all 3 numerators together in order from left to right. 25 plus 14 is 39, plus 20 is 59, all over a common denominator of 30. 59 and 30 do not share any common factors, so we can't reduce that any further, so this would be the correct answer for that expression. Our final example. Here we add in subtraction and addition at the same time. Well, to begin this problem, we again need to find a least common multiple or least common denominator. In this case, we'll quickly say that 24 is our least common denominator between these 3. And so we need to change each fraction so it has a denominator of 24. Well, the first one is already a number of 24ths and is good to go. The second fraction, I need to multiply by 4 in order to turn it into a number of 24ths. That will leave me with 4 24ths as the second fraction. My third and final fraction, I need to multiply by 2 over 2 in order to turn it into 14 24ths. Now that I have a common denominator of 24, I know that my answer will also be a number of 24ths. I simply have to add or subtract the numerators in order from left to right. Well, I take 5 minus 4, which gives me 1, plus the 14 gives me 15. So 15 24ths would be the sum of these 3 terms. But again, I can reduce a little bit further here. 15 can be rewritten as 3 times 5, and 24 can be rewritten as 3 times 8. I see a common factor of 3, which allows me to divide or cancel it out, and leaves me with a final answer of 5/8.